All right, so this review is very similar to what we did yesterday. It's part 2, right? Solving rational equations, and this is part 2. So let's just do number 1. Let's write this down. They put a K. I'm going to write an X. I write X's better than I write K's, so we'll just do it like this. Should be writing this stuff down. There should be nobody just sitting there with nothing in front of them. Everybody should be writing this down. Oops. I said I was going to not write K's, and then I wrote a K. And I was about to do it right here, too. X, what's this? Plus 4. And that's over 4x. All right, here we go. The hardest part about this, I think, anyway, is just finding the common denominator. You got a 4, you got a 4, and you got a 4x. I'm not really going to go through a big, long explanation of how to find the common denominator. A lot of talking. So I'm just going to tell you what it is. And the common denominator would be 4x, right? That's the number that 4 goes into, and 4x divides into. So we're going to multiply that by 4x. We're going to multiply this by 4x. And we're going to multiply this by 4x. I'm going to put this in parentheses, put this in parentheses, and put this into parentheses, because that could help us out a little bit. All right, so let's see what happens here. The reason we did that is so we could get rid of the denominators. That's the whole reason why we multiplied everything by a common denominator, so that we can cancel out the denominators, because we don't like the fractions. So I've got this 4 will divide into this 4. We'll write the rest of it down in a minute. This 4 divides into this 4. This whole 4x divides into this whole 4x. Let's see what we have left. So what do we have? We've got an x, and then we have times x plus 4. So we're going to have to multiply that in the next step. Then right here, same kind of thing. We have x, and then x minus 1. Right here, that whole 4x divided out, so nothing's being multiplied by this. Well, 1 is, but it's x plus 4. All right, so at least we took it out of fractions, right? So we don't have any more fractions. So now we just have to work this thing out. This is why it's part 2, because it's a little more involved than part 1 was. It's the same idea, though. That first step was really the same exact step as in lesson or worksheet 13. It's just at this point right now, it's just a little bit more involved. So what are we going to have to do with this x and this x plus 4? Distribute. So I've got x squared plus 4x, and then distribute this plus x squared minus x, and that equals x plus 4. Well, we got to simplify this. It's going to look like a what? Starts with a Q. Looks like a what? Quadratic, right? It's going to look like a quadratic. So let's try to simplify this so it looks like a quadratic. So first thing I would do is add like terms, yeah. So I got an x squared plus an x squared. That gives me a 2x squared. So I've added those up. I'm done with those. I got a plus 4x and a minus x. That gives me a plus 3x. I'm done with those. And then I'm going to put equals x plus 4. Okay? Pretty basic algebra stuff. Now I'm going to take everything, put it on the left-hand side. Because remember what I want this to look like. I want this to look like this. All right? I want all the stuff on the left-hand side, and I want it set equal to 0. So I have to get rid of this x. How do I get rid of this x? Subtract an x. So I'll subtract it from here. And then I want to subtract a 4. There's really nothing to subtract it from, so I'll just put minus 4 right here. So that went to 0. That went to 0. So what do I have on the right-hand side? I got a 0. Now, what do I have here? I didn't do anything to the x squared, so I'm just going to keep it 2x squared. And then plus 3x minus x, it's a plus 2x. And then I just have that minus 4. And there you go. So now, we took this, we turned it into a quadratic. Now we have to solve for x. So normally we would factor, correct? And we're going to do that here as well. But there's one thing that's a little bit tougher about this than in the last worksheet that we did. You didn't have a number out in front of that x squared yesterday, right? We just had x squared. We didn't have to worry about it. But this actually works out pretty nice because look, I've got a 2, and a 4. What divides evenly into both of those, or all three of those? A 2 does. So let's get rid of the 2. How do I get rid of that 2? Now, I'm not going to subtract it. What's that 2 doing to the x squared? It's multiplying. So it's multiplying by this, right? So I divide by 2, right? That way, I'll get rid of that 2 in front of the x squared. So I divide this by 2, divide this by 2, and divide this by 2. Remember, whatever you do to one side, you got to do to the other side, okay? Or whatever I do to one thing, I have to do to everything, right? That's why I divided everything by 2. Watch how nice this works out now. Those 2's cancel out, so I'm left with just an x squared. That's what I wanted to be left with, right? I didn't want a number out in front. Now, you can still work with it out in front, but it just makes it a lot easier to do it this way. So plus what? Well, those 2's cancel out, so that's an x. Minus what? 4 divided by 2? That's a 2. And that equals what? 0. Now, we took something that looked pretty complicated with these fractions, and we took that and we turned it into something that looks pretty familiar and should be fairly easy for us now to do, right? So now we factor. Some people might say, well, why don't you just use the quadratic formula? Well, you could if you wanted to. You could have taken that 2x squared plus 2x minus 4. You could have put that into the quadratic formula if you wanted to. But I think that's too much work. I think the quadratic formula is great, but it's great if you can't factor stuff. But you can factor this. I think it's a lot easier. It's a lot simpler if you factor. So I'm going to put an x here and an x here. Now, these two have to multiply to be -2, and they have to add up to be a +1. So what numbers, first of all, we're going to have a plus and a minus, correct? All right. So what numbers multiply to be 2? There's only one thing, 2 and a 1. But it all depends on which one's positive, which one's negative. So which one's going to be the positive? Because remember, they have to add up to be +1. So the 2 is going to be the positive, okay, and the 1 is going to be the negative. Let's just check. Do they multiply to be -2? Yep. Do they add up to be +1? Yep. So that checks, all right? That's how we factor. We've been talking about that for weeks and weeks now. We're almost finished. We're getting there. So what we have to do is set both of these equal to 0. If you have two things that are multiplied together and your answer is 0, you set them both equal to 0. So I take that x plus 2, set that equal to 0. Take that x minus 1, set that equal to 0. Let's do the math. We can do this in our head at this point, can't we? X is -2. X is +1. Now, it does say check for extraneous solutions, but do I have any square roots up here or anything like that? No. So if I put in a negative in here, it's still going to work. If I put in a positive in here, it's still going to work. So nothing's going to make that not work, okay? I shouldn't say nothing. I mean, either one of these will make it work, okay? Either one of them will make it work. So I can circle both of them, and that's my answer right there. It's -2 and 1, okay? So that's basically what this is all about. Let's look on page 2, see if there's anything more difficult than that. Number 11 looks kind of, well, let's do this. Yeah, go ahead. No. Remember the first thing I said earlier before I started recording? I said the problems are going to be exactly from the worksheets. Okay? So I've answered that question. Let's do number 10. 10 looks a little involved, so let's try that one. So it's a squared minus 4a minus 12 over a squared minus 10a plus 25 equals 6 over a minus 5, and then plus a minus 3, and that's over a minus 5. All right, and we got to solve for a. That looks crazy, doesn't it? But if you follow the steps that we've talked about, it won't be so bad. It's a little different than the last problem we did, but you should recognize to do something. What do you think you're going to do with this stuff right here? You're going to factor it. Exactly right. What do you think you're going to do with that stuff on the bottom? You're going to factor it. Let's do that first before we do anything else. Okay? Does that stand out to you? Does that pop out to you when you see that problem? When you see a trinomial like that, automatically, the first thing that triggers in my head is, hey, I should probably factor that thing, right? And that's exactly what we're going to do. We're going to factor this. So let's see what we get. We'll put 2 sets of parentheses. Now, again, I've talked about this many, many, many times, even once today. What multiplies to be negative? Well, first of all, let's put an A and an A. And they multiply to be negative. So one has to be positive and one has to be negative. Now, it has to multiply to be negative 12, and they have to add up to be negative 4. All right? Well, you have are you going to use 4 and 3? Can you get 4 and 3 to add up to be a negative 4? So what are you going to use? 6 and 2. Right. Use 6 and 2. That's how we can get a 4 out of it. Okay? Especially if one's negative, correct? Now, our answer is negative. So if I use 6 and 2, which one is going to be negative? The 6 is. So the 6 is going to be the negative, and then the 2 is going to be the positive. Let's just check to see if it works. Negative 6 times 2. What's negative 6 times 2? It's negative 12. That works, right? But you got to add them up, and it has to add up to be this middle one. Do they add up to be negative 4? Sure. 2 plus negative 6, or negative 6 plus 2 is negative 4, so that does work. We getting okay with the factoring now? Yeah, this should be like second nature to us. All right, let's do it again, but we're going to do it on the bottom this time. Put an A here and an A here. Now, they multiply to be positive, but they add up to be what? Negative. So what are my signs going to be? Negative and negative. They can't both be positive. Now, that'll give you a positive 25, but they have to be negative. Can you add up 2 positive numbers to get a negative answer? No. So they both have to be negative, right? This is pretty easy. So it's 25. What times what is 25? 5 times 5. Does that add up to negative 10? Absolutely. So 5 and a 5. They multiply to be positive 25, and they add up to be negative 10. So we're good with that. Everybody see that? All right. So that was a big part of the work on this, but really it just set us up to get rid of the denominators. So now what we're basically doing is what we did in part 1 of this worksheet, which would have been what? 13? Worksheet 13? All right. So now let's take a look at this. Let's go to yellow again. It's kind of been our theme. Look at our denominators. This one is a minus 5, a minus 5. This one is just 1a minus 5, and this one is just 1a minus 5. So what would your common denominator be? That's right. Okay, or I think we'll confuse people if we say squared, but let's just say a minus 5 times a minus 5. Okay, that would be your common denominator. So I'm going to multiply this by a minus 5 times what? A minus 5. Okay, then I'm going to take this and I'm going to multiply this by a minus 5 times a minus 5. Then I'm going to multiply this by a minus 5 times a minus 5. So what I did is I found my common denominator and I multiplied everything by that common denominator. The reason we did that is so that my denominators will all cancel out and I don't have any fractions. That's the key to this. So what cancels out here? Everything, right? All that cancels with all of this. So all I do is just multiply that and bring it down. We'll do that in a second. What happens here? What cancels out here? Just one of them does, right? So you got an a minus 5 here. It only cancels out with one of them. I still have one left, so I'm going to have to multiply those together in a second. Same exact thing here. This a minus 5 cancels with this a minus 5. Everybody good? Everybody watching? Got a few nodding off. This is the very last lesson, the last time that we teach anything brand new, so it'd be a good time to stay awake. So let's take a look. We're going to multiply those together. Give me a word that we use to multiply those together. What is it?
Foil.
Foil. Right, let's use foil. Okay, you could say, I think I heard, it's already factored. We're not going to factor it. It's already factored. So we're going to foil it, okay? Or multiply them, distribute, whatever you want to say. But I was looking for foil. So let's do it. First, outside, inside, last. So the first would be what? A squared. Let's do the outside and inside at the same time. I think we're at a point now where we should be able to do that. So it's a times negative 6, which is negative 6a. plus 2a. Can you do that in your head? Negative 6a plus 2a? Negative 4a. In fact, actually, you know what? Hold up. Yeah, we want to do that. All right. It's going to be what we got up there, isn't it? Because I factored it. So technically, it looks like we didn't even have to factor it. But that's the first thing that popped in my head was to factor it, so I did. So anyway, it was kind of a wasted step right there, but it's no big deal. So it's a squared, what? Minus 4a minus 12. Okay? Now, we got nothing on the bottom, so we just don't put anything on the bottom. So what do we do here? Distribute that. So what's that going to be? 6a minus 30. Good. All right, and then right here, plus. Now on this one, we're definitely going to have to do distributive property or FOIL, right? Same kind of thing that we did here. So let's do that. What do we get? A squared, right? Minus 5a minus 3a. What's minus 5a minus 3a? Minus 8a. And then the last is plus 15. Okay? And now, we just got to solve for a. It actually works out kind of nice because what happens to the a squareds? They cancel out, right? Subtract an a squared from both sides. Everybody see that? I'm just going to mark it out, okay? So I know that that's going to happen. Let's just add like terms, okay? Let's just keep this over here. I don't want to do too much. I was trying to think of easier ways to do it, but let's just add like terms. So what do we have here? We got 6a minus 8a. What's 6a minus 8a? It's negative 2a, correct? 6 minus 8? Yes? Anybody here? All right. What about this? Negative 30 plus 15. That's what? Negative 15, correct? Okay. So I added like terms. Now we want to get everything on the same side. Doesn't matter what side you put it on, but I have a preference, a personal preference. You don't have to do it like this, but I would add a 4a. Why would I do that? Why would I put it on the right side? Because we usually put it on the left side, don't we? But I put it on the right side because it'll make it a positive a. That's why I did that. All right, so I'm done with that. In the same step, let's get rid of this 15. So I would add a 15. That cancels. Bring everything down. Negative 12 plus 15 is 3. Bring this down to a. Divide by 2. There it is. A is 3 over 2. That's it. It was a lot of steps. I grant that to you, okay? It's definitely a lot of steps. But really, there was no steps in here that were extremely hard. I don't know, what do you think the hardest thing was? Just to factor these maybe? Okay? Distributive property or FOIL method, was that the hardest part? Maybe knowing what to do with the common denominator or finding the common denominator? I don't know. But yeah, there were some steps in there for sure. But I don't think any of those were beyond what you're capable of doing. It's just putting it all together. That's the hardest part. Carter? 14? Okay. This will be the last one we do because we got 2 more worksheets. Well, 16, we've gone over quite a bit. But what are we doing? What'd you say, 14? Okay. I'm going to go a little faster. You're probably thinking I'm already going fast enough. But it is being recorded, so you can always look at it and slow it down, stop it, rewind it. Has anybody ever done that? You've actually watched one of these lessons and I went too fast and you stopped it, you rewound it a little bit and then listened to it again?
I've done it once.
Okay, one time all year out of all these videos I put up? Okay.
I'm being honest.
No, you are being honest. That's good. So let's see. What do you think we're going to do here? I would factor it, wouldn't you? So it's greatest common factor. So just pull out the p from here. What am I left with? P minus 4 plus 1. Just put a plus 1 right there. Equals p minus 6 over p. All right. Here's the part that I have a feeling this might be the hardest part for you to see. But I've got, what do I have as my denominators? I have a p and a p minus 4. I got a p right here. That doesn't sound too good, does it? I usually, sorry. I won't. So I got there's a p right here, p minus 4, and there's a p right here. So what's my common denominator then? It's p times p minus 4. Now I'm going to multiply everything by that. Multiply this by p times p minus 4. Multiply this by p. Oops. Put a p times p minus 4 right there. Okay? All right, so what happens? The reason we did that is so we could cancel out the denominators. Well, everything cancels out here, so that's nice. I'm just left with a 1. There was no denominator here, so there's nothing to cancel out. Right here, there's one thing to cancel out, would be that p right there. All right? So let me change this back to white. Let's see what we have left over. After canceling all that stuff, what am I left with here? Just a 1. Plus, what's this going to be? P times p minus 4. But let's go ahead and distribute right now. So that'd be p squared minus 4p. What cancels out here? Those two. So what are we going to do with these two things right here? We're going to FOIL it, right? So let's FOIL it. Can you FOIL it with that p in the middle right there? I mean, it's canceled out, so it's not really there, but let's do it. What do we get? P squared minus 4p minus 6p. What's minus 4 minus 6? Negative 4 minus 6. It's negative 10. And then what's the last part? Multiply them together. Negative 6 times negative 4 is positive 24. Okay? And the rest is kind of like the other one. Look, the p squareds cancel out. Let's put the 10p over on the left-hand side this time. Let's put the 1 over here. That cancels. What's this? 6p. That canceled. This is what? 23. So your answer, 23 over 6. That's how you do it. All right, let's move on. We got to get to another worksheet. It's 12 after. I got 13 more minutes. 13 more minutes. It is hot in here. I don't know how to change the thermostat. Can you do that? Yeah, go ahead. Yeah, it's burning up in here. All right, so Pythagorean Theorem, here we go. We shouldn't have to take too long on this, should we? Yes. Let's do number 1. This one's really easy. You shouldn't have to do any work. You shouldn't even have to barely even think about this one. But you do have to remember something, though. You had this on the quiz, didn't you? Did we have this on the quiz?
What?
Yeah.
Without doing any work at all, I can tell you what this answer is. It's not because I'm super smart. It's just because I know a couple of Pythagorean triples. That's right. What's the easiest Pythagorean triple? 3, 4, what? 5. What's the second easiest one? 5, 12, 13. Okay? There's some other ones, but those are really the most common ones. Okay? So what is x? It's just 5. Okay? That's all you had to do. On the quiz, a lot of you guys, I think, did we have this on the quiz or was it another class? Okay, well, anyway, there you go. Right, because it was just 16 on the quiz, wasn't it? Yeah, it was my other class, and I was yelling at them. They were doing all this work. They were doing Pythagorean Theorem. I wasn't yelling at them for doing Pythagorean Theorem, but I was kind of telling, and I wasn't really yelling. I was just kind of being a little loud. So anyway, it's just so easy. If you know your Pythagorean triples, you should be able to just look at it and write it down. If not, you could do Pythagorean Theorem. Let's do it really quick. Let's say you didn't remember this right here. Let's say you didn't remember that. All right? So how would we do this? You'd go, well, let's go to the x first. Let's go x squared plus 12 squared, and that will equal 13 squared. Why? Because a squared plus b squared equals what? C squared. C is always the what? The hypotenuse. The a and the b are the other two legs. It doesn't matter what order you add them up, but C has to be the hypotenuse. That's very, very important. Let's do the work. X squared plus 144 equals, what's that, 169? All right, subtract 144 from both sides, 144, and that will give you 25. So x squared is 25. Get the squared out of there. So square root it. So what's the square root of 25? It's 5, and that's your answer. But look, wouldn't it be a lot easier to recognize that it was a 5, 12, 13 triangle? Yeah, it would have been. All right, but you could still do it with Pythagorean Theorem. No big deal. Let's do another one, and then we'll do 16. We'll do worksheet 16. Anybody have a... well, we'll do 2 more because there's another type of problem on there. All right, let's do number 7. Let's do number 7. They don't give you a triangle. They just give you the information, right? Which is really all we need anyway. And it says, solve for the missing side. So what's the missing side here? It would be B, wouldn't it? So they don't even give you a triangle, right? But you should be able to do it without the triangle. A squared plus B squared equals C squared. So I'm going to go what? 11 squared plus B squared equals C squared, right? You don't really need the triangle, do you? As long as they tell you the sides and the hypotenuse, guys? So let's do this. What's this? 121 plus B squared. What's that? 225, is that right? Okay. 225. Subtract a 121. So B squared equals, what's that? 4. That's 104, is that right? Okay, so what's B equal to? Square root of 104. You may have to simplify that. You do. So I use a calculator. Watch, here's 104. Break it down. 2 goes into it, right? 50 2 times? 2 times 52, yeah. 2 goes into 52. What's that, 26? Whoops, 26. You got another 2 right there. Now look, I can stop right there. Would you agree? Because look, what can I take? What can I take? It has nothing to do with that. What is the 2 times 2 is what? 4 times 26. Then you split this up. It's the square root of 4 times the square root of 26. What's the square root of 4? It's 2 square root of 26. That's how you would simplify it right there. Yes, ma'am. You may. All right, let's do another one. This is the one where you have to tell if it's right, acute, or obtuse, okay? And I'm just going to give you 3 numbers, and you have to tell me what it is. I'll just give you some regular numbers. So what if I told you one side was 9, the other side was 12, and the other side is 17? And you have to tell me, is this a right triangle, is it an obtuse triangle, or is it an acute triangle? How in the world do we do that? Well, we take the Pythagorean Theorem, and we write it kind of a little bit backwards. We put the C first, okay? So if C equals A squared plus B squared, what kind of a triangle is it? If I take this and square it, then I square these and add them up. If they're equal to each other, what kind of a triangle would that make it? It'd make it a right triangle. What if C squared was less than A squared plus B squared? What kind of a triangle would it be? Less than. What word goes with less than? Is acute or obtuse go with less than? Acute goes with less than. And if C squared is greater than A squared plus B squared, then obviously the only one left, it would be obtuse. So that's what we have to do with this. So which one is the A, B, and the C? What's the important one? The C. Which one is it? It's the 17. It doesn't matter which one the A and B is, okay? We'll just call that the A and the B, all right? So what do? We use this right here, and we see which one it is. So we take the 17, we do it first, and we square it. And then we compare it. I don't know if it's equal, don't know if it's less than, don't know if it's greater than just yet. So I'm going to put a question mark, all right? And then let's take the other 2 sides, square them, and then add them up. I should know 17 squared. 289, is that what it is? Okay, so 289, and what's that? 81 and 144. So that's 289. What's this? That's a 5, and that's a 2. Is that a 22? 225? Is that right? Okay. What is 289 compared to 225? It's greater than. So what kind of a triangle is this? It's obtuse. All right? So if I give you a problem like this, I need to see this right there. You cannot just write this is number 15 on the worksheet. You can't just write obtuse and get it correct. It will be marked wrong. If all you do is just write obtuse, I will mark it wrong. Okay? You must show why it's obtuse. This right here has to be in there. Everybody understand me on that? So make sure you don't just take a 1 in 3 chance and get the right answer. It's not going to be right unless you show why it's obtuse. All right, enough of that. Let's move to lesson or worksheet 16. This is that 45. Ooh, I'm running out of time. But you can go back and watch the video when I taught this. We've had a quiz on it and everything. We even went over the quiz. So we've done this a lot. I'll tell you what, since I only have 4 minutes left, let me just basically go over. I probably won't have time to do an example, but here we go. Let's just do this. All right, so if this is 45 degrees, that means this right here is going to be 45 degrees. All right? This is called a leg. This is called a leg. They're both called legs because they're both exactly the same thing. This obviously is called the what? Hypotenuse. So we had a formula. Its hypotenuse is equal to the square root of 2 times one of the legs. So you need to know that. We had another type of triangle. We had one that looks something like this. It's a little bit too long, but that's okay. So if this was 30, what's this going to be? 60. This is, we call the what? The short leg, and this is the long leg. This is always the hypotenuse. We had 2 things to remember with this. Okay, and they both relate to the short leg. The long leg and the hypotenuse both relate to the short leg. Let's do the hypotenuse one first. That's the easiest one. The hypotenuse is twice the short leg. And then the longer leg is what? What's the number? Square root of 3, right, times the short leg. All right? So, those are the things that you have to know. You got to memorize those. I don't have time to do any examples on this today, so go back and watch the lesson. I don't think I recorded us going over the quiz or anything. I know I didn't do that. But you can look at the quiz. Some of you, I still have it, but I'll grade it next period. And if you really want your quiz back, which you probably do, so you can use it to study for the quiz, you can come see me after next period. Okay? Everybody good?
Yeah.
Look at that. We are finished.